Hello, welcome to Module 12. This is the last module that we're going to be working on in this semester set, and there's two PowerPoints for this module. The first one is going to just talk about weather forecasting analysis, and you'll see I'm going to skip a few slides here and there because some of them are just definition based, but we're just talking about stuff that you've been working on all semester. On how to forecast information and also how to analyze this forecasting information so that you can see and do more in the future. So really quickly, the two abbreviations that you're going to need is National Weather Service, which is NWS, and Meteorological Service of Canada, which is MSC. And both of these organizations employ meteorologists 24/7. So it's constant. There's constantly somebody on the monitors analyzing data. Now, the monitors and what they're bringing in is not image-based. It's actually coming in as number skews, and those number skews are then input into a system, which is the Advanced Weather Interactive Processing System, or the AWIPS. That system is the one that we input that information to create computer output models for everyone to look at and interpret what's going on. So it allows us to create that satellite imagery with station points with information about those station points on them. Weather and forecasting in general is considered both an art and a science because we do look into modules, and we want modules that are showing accurate bits of science but are also visually able to portray the information that we are trying to explain in number format. So here is an example of a United States weather map, and we see some different pieces of predictive information shown. And so right here is a frontal line. You can see your fronts, right? So we have here a front line, so cold front over here, a little warm front right there, right? Warm front, cold front over here, high and low pressures on my image. And then they're also giving me these dotted lines, which are showing me regions of possible snow in the white lines and regions of possible rain in these orangey colored lines. And so this is creating a visual piece of information to help us interpret what is going on in various regions. One of the big things that people find is that they feel that weather is incredibly inaccurate, and that's actually not true, considering the fact that we're attempting to predict the future activities based on what we are seeing in module information. We're actually incredibly accurate in weather and meteorology in general, and it's pretty impressive actually how far the science has come. And with that said, it's actually gotten even more accurate in even the last 10 years. It's made some real leaps and bounds. As far as the different forecasting methods, there is the climatological method of forecasting, which is the long-term average, where we're talking about seasonality or yearly things, or something that takes multiple months to take place. So we might say that this seems like, because of the temperature of the surface water on the oceans and the presence of easterly waves, right? Talking about the last module that we just had, we would predict that there is potential for this season to be a severe hurricane season. That might be a climatological forecast that we could get. Persistence forecasting is based on current conditions. This is talking about what's currently going on and what we would predict in the current conditions. So this would be like in the wake of the storm. We would be talking about the storm surge and then the bay and storm surge heights, for example. And we might be doing it moment to moment within the actual event taking place. Analog approach, this is the current conditions, but they are basing them off of past conditions, so it's a comparative. We're doing comparative, and you'll hear stuff that would fall under analog approach when we say things like, this year is the warmest year on record for this date or this time, and that would be an analog method because we're basically comparing it to past years. And then there's the numerological weather forecasting, which is computer algorithm based, where I'm taking in multiple bits of information, things like the current temperature and the dew point temperature and the humidity at this time, and I'm creating predictive models based on my current numerical information as it's coming in. There are basically three types of forecasting. There is the quantitative forecast, which is a literal number. This is how many inches of rain I'm getting. This is how many inches of snow I will receive. This is how much rainfall I will receive in an hour. This is the temperature high of today. This is the temperature low of today. That's my quantitative forecast. There is a qualitative forecast. This is the more ambiguous or loose numbers, where I will say there is a predictable chance of rain, right? Or there is no predictable chance of rain for today, where it's not giving you specific times or numbers within that set, but kind of a loose information. I might say that there is a chance of partly cloudy skies, right? That would be a qualitative forecast. And then there's probability forecasting. This is where I will put in a percentage. So instead of just saying there is no chance of rain or there is a chance of rain, I will give you a percentage and say like 90% chance of rain. So these are all different bits or ways that I can predict what's about to happen, and they basically fall into these three categories. One of the things that you will see on the exam is something very simple, where I'll give you something that says today's high temperature for the day is 68 degrees. What type of forecasting would this be? And you would say it's a quantitative forecast, right? Or I might say that there is a 20% chance of snow for today, and you would say that it's a probability. Or I might say that there is a slight chance of overcast skies, and you would say it is a qualitative forecast. So those are examples. Another way to think of it is looking at it in visual format. So now we're going into showing the actual quantitative information. So how many inches of rain will I receive, but doing it on a visual scale. So I can actually see that here I have my color regimes, and it gives me that scale where I would say like, oh, it's green here. That means it's 0.75 inches. So a little less than an inch of rain I would receive in this image model here. So just another way I can show it. As far as assessing forecasts, there's different measurements that I can do, and we've already talked about the measurements that goes all the way back to Module 1. And so what am I doing? But this is all about interpretation of those measurements. So we take into account, when we receive information from a weather station, how accurate that information would be. And so we would say forecast quality and the value of that forecast as it was assessed. For example, I might put a higher value over my satellite imaging in lieu of maybe a ship log where somebody logged it in based on a ground visual of it. I might say like, oh, well, the satellite flyover has a greater forecasting quality to it in its accuracy, as opposed to somebody who's below the storm looking up at it, especially if they're trying to give me numbers of like how big is the storm, right? So we would go into that. Another thing is to assess the forecasting accuracy, and then forecasting bias. Bias can have a few different things set on it. Some of it is informational. So it's how I'm taking that information and the way that the information is being received. And another one can be regional. For example, I might see low pressure, but I'm over the equatorial zone, so I will have a forecasting bias and predict that it would result in an afternoon rain as opposed to the formulation of a hurricane, because that's not a commonplace action to take place. So it's, there's biases in two different formats. And then forecasting skill. As far as other organizations that determine whether, there's the World Meteorological Organization, or WMO, and this is a global database for all information, and this information is collected based on land stations that have input into it, and the National Weather Service does give their information to the World Meteorological Organization too. And there's also ship stations, And then there's buoys out in the ocean that tell this information. And then there's also our international weather satellites. And we still launch weather balloons, but it's becoming less and less common. We don't do it as often as we used to. And there are certain